1 2 1 1. Okay, so it's time to begin, or actually 10 minutes passed. So in this live session I'm going to show how to create a simple domino-like game, which you can see here. The purpose of the game is to move the tiles from the source through the filter and to destination. Unlike previous live sessions, this one will not show how to create the complete game from scratch, because it takes about 16 hours. But if you want to have a look at the complete process, you can have a look at it here. I will be referencing and using the assets created here, the scripts created here. So let's create a new project. And save it as Domino live session. Okay, as you can see, I have saved the default empty project as Domino live session. Yep. So the empty project, the first thing I will explain is what an empty project consists of. So empty project is the project which displays the bare minimum of what Open Game Studio editor can do. In this case, in the case of the default empty project, it contains a ball, contains camera through which we see the world, and contains light to light the ball. Now, if we press space, it says start and rotates, and that is all it does. So we're going to change it to a complete domino game I have shown before. So how do we do it? Well, the first thing we did already, it was to save the empty project at the new location. Before we continue, I should explain what the details of the empty project. So as you can see, empty project is located here, and it is also shipped with the editor, and it is the default project that is opened by the editor when it starts. So the default project contains what? The first file, default actions. Default actions. What are actions? Actions are node property changes across time. In this case, this is a rotate action called rotate ball in the group default, and its properties are 2 points, which mean that in 1 second the node that rotate ball is applied to. The node should rotate by Y by 360 degrees, which is actually what happens here when I press space. The rotate ball action is performed for the ball node, and that's it. Now default composer. Default composer contains declaration of texture template to use, which describes how to generate a texture in memory from files on the disk. For now, that's non-essential and should be left as is. The next lines are important. The next lines define materials. In our case, only one material named ball in the group main, which consists of one diffuse texture and one normal texture. Let's have a look at both textures. As you can see, they reference files relative to the directory of the project. So we go to pipeline textures and see the files. So the normal map is nothing interesting in our case, but it is important to specify for lighting to work correctly. Without normal map, the lighting is wrong. We can see how wrong. Okay, that's weird. That's not weird. Let us restart the editor. Domino live session. So, as you can see, current material is ball. Let's change it to something like none, which is no material. And as you can see, the lighting became strange and not exactly correct. That's because there is no normal map assigned and no normal map is used. Let's return to ball. Now the lighting is correct. So normal map is important for correct lighting. Now let's have a look at diffuse texture. As you can see, okay, that's weird. It contains the color of the node, the base color of the node, before lighting and any other effects are applied. So, one material consists at least of two textures. Diffuse one, and normal one. Now let's go to the next file. It's default lights. It contains a list of lights that are used, that can be referenced by the light node. Here you can see that the light node references the light named default. We can also reference non-light, but as you can see, the shadows are not correct if we do that. So, the light specification of named default in the group default specifies the following things: shadow jittering scale, it means how dispersed shadow is; shadow fragment shader, it's a shader to use for shadows, to generate shadows; and the last parameter is shadow texture size, which says how much pixels to use for the texture. The more we use, the better the shadow. The less we use, the worse the shadow. So we can see that now with 124 by 124, it's pretty good. We can change it. Let's change it to something really small, like 128, and it should be noticeable. Reload the project and as you can see, the shadows are ugly because there's simply not enough pixels for a correct one. As you can see, during the rotation the shadow flickers a lot. So 124 is a good default value for that. That's why it's set as such by default. So let's reload the project. As you can see, it's a lot better. Now let's go to the next file, default scene. Default scene is scene graph. It lists the nodes that are in the scene, and for now you can also see those nodes here. And default scene also lists some of the properties you can see on the right. So as you can see, the light node position is as follows. It references light default, and it references script main. There is no requirement how scripts are named, but for consistency, main is the main script that actually listens to the space when I press it and activates the action to rotate the ball. And the parent of light is root, which means the root of the scene graph. We also have camera node, the same parent, different position, and also rotation is specified. As you can see here, only position is specified for light, but for camera, rotation is specified too. Camera uses camera sync script that helps control the editor, helps control the camera by the editor. Yeah, helps editor to control the camera. Without it, it wouldn't be possible, so it is set by default. This should not be changed for now. Now, the last node and the only visible in the scene is ball. So it has rotation, it also has material named ball, it references the model named ball OSGT, and it is assigned a script vol pi. Now let's go to the next file. It's default sounds. Default sounds lists the sounds to load when the project starts, and as you can see here, we only load one sound buffer named start in the group default from the file sounds start OGG. Start OGG is what you hear when I press space. So as you saw, the sound simply contains some robot-like start spelled. Let's go to the directory now, models. It contains only one model, ball OSGT. OSGT model is generated by Blender using OpenSceneGraph exporter. OSGT means OpenSceneGraph text format for models. We can have a look at it since it's textual. Basically, display contains vertices and their connections, just numbers, basically, all the vertices. So these files can get pretty big. They also contain information to apply textures correctly. Okay, let's go to the next file, to the next directory. It's pipeline and textures. As we already saw, it contains two textures for now, the normal map for the ball and the diffuse map for the ball, which together constitute material. Now each project also contains player shortcuts. Player shortcuts is a list of shortcuts that for the player. So, for example, when user presses left mouse button, the shortcut named select of the group node is reported to the player. Now, how do we spawn the player? The player can be spawned right from the editor. It's called play. This is the player and this is the editor. The player is simply the player of the project that has been created with an editor. It does the same thing, so but it's a complete game. You cannot edit things here. You can just play when it is ready. For now, player is not shipped separately, and yeah, because it's too early for now, but you can preview what you have created easily with just play. Now let's continue the overview of the OG Studio project. We also have README, which explains what each file means, basically what I am explaining now. Since we are creating Domino live session project, let's update it. This is Domino live session project for open. Okay, that has been created on 28th May 2016. Overview. This project contains a simple. It will contain, but for now I write for the state when we finish it. So when once we finish it, which will be in approximately 2.5 hours, this project contains a simple domino-based game where you need to move tiles from source plate to destination plate. Destination 1 through filter. Okay, let's remove the word plate. From source to destination through filter. We won't go into details. As you can see, there is no Git repository for now. We will do that later a little bit. So we have seen README file. Now let's go to the let's have a look at source. The source is not really, it only is present in the empty project, in the default empty project, just for the reference to see, to contain the source of the models. Let's have a look at it. Let's open Blender and let's open Domino live session, source and models. So as you can see, there's a press space text which you see here. It was used to generate the text on the texture. You can also see the ball that has been exported through file, export, OSG model, OSGT, and that's basically it. We won't go into details of how to generate, how to create a text, how to create a model, how to generate OSGT, how to generate normal map from the model. If you are interested in this, you can have a look at it here, because here I did it all from scratch. So I created the leaf model, I created source model, I created filter model, destination model, tile model, LCD digit model, LCD base model, and just base model. So if you want to know how exactly to export from Blender, how to create with Blender. Go there. For our purpose, there is no need for the source. No, actually we do. No, we don't need source directory, because we will copy it from the project, from the Domino rehearsal project, which has been created in these videos. These videos depict how it was created. So Domino rehearsal. In this live session, we will use Domino rehearsal project assets and scripts to save time. Again, if you want to have a look at the whole process from scratch, you can see it at YouTube, and you can see at GitHub the project, how it looks like. But let's go back to the scripts. Let's have a look at the scripts, how they look like. For now, scripts are in Python language. The scripts, the entry point for each script is the function named script create, and when the script is deallocated, the script destroys code. So in our case, the simple main script is attached to the light, as you can see here, and when it is created, it starts to listen to space key press, and also it listens to the ball when it stops moving. So on space is called when I press space. Let's see. So when I press space, we first play the sound, and then we start the ball, ball rotation. However, ball rotation does not happen by using the action explicitly, because we also have the ball script, which provides certain API for its motion, namely the moving call. When the main script calls ball dot moving equals 1, or sets that to 1, the ball activates the action, which rotates the ball, and when the action stops, it reports that it has stopped. So scripts provide, each script provide some portion of game API. In our case, the main script simply listens to space press, and the ball, which is assigned the ball script, listens to its moving call, and when assigned moving, it moves and then stops, and yeah, that's it. Just two simple scripts, ball and main. Now let's have a look at the sounds directory. Well, it contains only the actual file and the readme for the file. The readme simply tells where it came from, so the full URL, and the original file name. As you can see, the original file name was not OGG but different format, so I converted it. So now I have explained what an empty project looks like. Again, it contains of several basic files that every project should have, namely the actions, which contain node property changes, compositor, which contains materials for nodes, lights, which contains lights that can be referenced by light nodes, scene, which contains the scene graph to display, sounds, which contains a list of sounds, used by the project, by the game. Model directory, which contains the ball model exported from Blender, which the project also contains pipeline, which can contain the quite complicated pipeline files like shaders and other stuff, but for a simple project like this one, we only need pipeline textures to contain just our textures, normal textures and diffuse textures, and that's enough to get results already. Now, player shortcuts, which tells the player how to understand different input. The readme, which simply now contains a bit of information when it has been created, that is today, and that it's for a simple game. Now there's also the scripts directory, and as we have seen just a few minutes ago, it contains the ball script and the main script. As you can see also in the documentation, the ball moving call, API call, it is provided by the ball script, and main script simply subscribes to space press to call the ball moving API call, and that's it. So the sounds directory contains the sound and readme of the original start sound file. We also had source directory, which contained the Blender file for the ball, but I just removed it. So I have just explained the empty project briefly, what it contains of, what it has, and now we should start doing the Domino game. So how do we start? Well, first thing to do is to delete the ball, because who needs the ball? Let's reopen it. Okay, we can even shut it down. So let's remove the ball's model, because we will not need it. Now let's remove the ball textures, because we will not need it. Let's remove scripts, because we won't need these scripts. However, we will leave the sound, because the same sound is referenced again. We will also keep these files, because they must be present for... They will be simply overridden once I start copying the rehearsal project. So git status. Let's init the Git repository. Let's copy the git ignore file, so that non-necessary files are not added to the repository later. Now let's create the new Git repository where the live session assets, scripts and everything will be kept. So let's create a Domino live session, Domino based game, to move tiles from source through filter to destination. Yeah, the explanation is a little bit weird, but okay. So since we have created the repository here at our local computer. So let's recheck it, and as you can see, this is the Domino live session project that I will push to while I recreate the Domino game. Now, what do we have now? Well, basically, let's open the Domino live session. Alright, after I removed the pipeline texture files, I didn't remove them from the compositor, they are still referenced. Material main bowl. Alright, let's reopen live session. Okay, looks like I should not have done it. The bowl texture and the bowl normal texture should be left as is, because apparently the editor cannot have no textures. That's not perfect, but anyway, we can actually still remove the, we don't need those textures. So what we need, the first thing to do is to add now let's return the bowl textures. Because if they are needed that much, let's return them and let's restart it. Domino live session. Oh, god damn it. Now that's becoming weird. Okay, let's resave the Domino live session just so that it works correctly. Okay, let's leave the bowl. I should not remove old resources just now. Let them be for now. Let them be for now. Still, we do remove the bowl. Let's reopen Domino live session. Yes, correct. Now the first thing we need to do is to add add the base node, which will contain basically all the scene. So let's do this. Copy from Domino rehearsal modals base OSGT to the modals. Let's add that node, empty node, base. Let's select its modal as the base. Okay, as you can see, the lighting is wrong, as I said before. That's because no normal map is present. Let's save the camera position to this one. Save and reopen. So what we need to copy now is the base material. Let's do this. So, but before material, let's copy textures first. So copy base textures. And now describe its material. So base material references base texture and base normal texture. Now go back here, reload and select material to base. As you can see, lighting is correct now because normal map and diffuse map are used, so it is a lot better. Okay, let's save camera position as this. Reopen. Okay, now what we need to do is add the source for the tiles. So let's copy the source model. Source OSGT to models. And since we will need source material right away, let's copy source textures right away. Reopen. Add new node, call it source, and assign it the model, the source model. Okay, make it child of the base, because as you can see, once we make the child of the base, the materials are inherited. If it's not a child, it uses some default material, which is pretty ugly. This material, when it is inherited by the source, is a little bit better, but as you can see, it's still ugly because it's not the source material. It's just the base material applied to the child named source. Now first, let's position the source correctly. Let's go to the left, more to the left. Use orthographic projection. Orthographic projection is useful to when fine-tuning is necessary, and fine-tuning is necessary right now. So this position looks like this, like correct one. Let's move it up. Let's see from the side. So that position seems to be correct. Looks good. Yeah, looks good. Let's save it. Now we also need the source material. Let's reference the copied textures. Okay, let's reload. Select the source and select a new material, source. As you can see, it's now better. Okay, now the source also needs tile slots called leaves. Let's copy leaf model and leaf textures. So models, leaf OSGT to models, and pipeline textures leaf to pipeline textures. As you can see, we only copied the normal map of the leaf because the color is inherited from the parent. Let's reopen it. Let's add the node, call it source leaf 0 more correctly. Set its node to leaf and assign it to source. Let's move it up a little bit, or move it aside a little bit. As you can see, Here it is. Again, it inherits the material of the parent, and it looks ugly, but we will fix it in a moment. First, let's position it correctly. Yeah, that looks like the correct position. Now let's create the source, the leaf material. Now leaf material, as I said, is different. It only uses its own normal map, but not diffuse map. Diffuse map is inherited from the parent, so let's reopen, select the leaf, and select its new material named leaf. As you can see, the lighting is correct now. Yep. Now we need 5 more leaves here. 1, 2, 3, 4, and 5. So how do we do that? We need a special parent node. Let's go like that. We assign it to the source, and now we copy the source leaf and paste it to the parent intermediary node, because it will use to rotate the leaf easily by 60 degrees. And as you can see, this is leaf 1, this is leaf 0. For now we cannot rotate the leaf alone around some object, so we had to use the intermediary parent node. Let's save, let's add another leaf. Let's rotate it by 120. Let's copy it and let's paste it. Let's rotate it some more. Okay, let's add 2 more leaves. Uh, 240. Let's copy, paste, and the last one is 300. Okay. Let's reload. And as you can see, the source is ready now. It has 6 tile slots. We have the base in the scene, we have the source, and the source has 6 leaves which will contain tiles. Let's reload. Okay, so what do we do now? We have the static beginning of the scene, and it is pretty dead. Yeah, it's pretty dead. So what we need is to copy the source script and also the main script. So let's copy the main and the source scripts from rehearsal project. So copy main into scripts and copy source into scripts. Now, since we also need to create tiles, not just to bring source to life, we also need to copy tile factory to scripts. Tile factory is used to create tiles, and as you can see, we will later copy destination, filter, LCD scripts. For now we only copied what? The main, the source, and the tile factory. Okay, let's save and reopen. Now, for the sake of convenience, we will remove the ball material because it's unnecessary. Let's reopen. to make sure it works fine. Now we also remove the ball model. The ball model, remove it. Let's recheck. Yep, works fine. And remove ball textures because we don't need them again. Let's reload, works fine. And now let's remove the ball scripts. So we got rid almost of everything that we had from the empty project. Now it's already a new project. So what we have done for now, we added 3 new models: base, leaf and source. We added several textures for the base, for the leaf and for the source materials, and we added the main, source and tile factory scripts. Let's assign the scripts. The light can have tile factory. No, light should have. Alright. Wait a second. Reopen the live session. Okay, the main script cannot be instantiated somehow. I have some suspicion. Let's check it out. So let's first assign the script to the source because it should work fine. Let's assign the tile factory. That should work fine. However, when we assign the light, the main to the light, it crashes. Well, that's not what I expected. Let's commit and push source and the base in the scene. As I already told, Domino live session project. Okay, readme has been screwed. Wait a second, readme. Hi. Okay, this is a Domino project. It has been created during May 28, 2016 Open Game Studio live session. Okay, just updated readme so that it is not lost. Oops, okay, let's reload here. Now, what I wanted to tell is that what I do now, I save a Domino live session project at GitHub. So, what is our current progress? Again, we have created the base, the source and the leaves by copying the assets, namely the models, from the rehearsal project. Then we also assigned tile factory script to the base and source script to the source. And also when I try to assign the main script to the light, it crashes, which means the main script references something that does not yet exist because I have not copied everything from the rehearsal project. So that's okay. Oh, it crashes because the main script requires the sequences file. Let's start it. Sequences. And now the important information about sequences. The sequences file contains behavior of the game. So the first sequence we have in the game is start, And what can we do when we start the game? That is, press the space. Well, we can replay the sound. Let's check the main. Okay, the main has what? The main has the following call: main replay start sound. So let's do that. Main replay start sound. So when the start sequence is executed, the first thing it will do is replay the start sound, and that should be enough for assignment. Yes, I assigned the main script to the light and it has not crashed. Let's reopen and press space. Okay, let's press space. Okay, as you heard, it said start. And how it said start? Again, by executing that call. So when the start sequence is executed, the following call is performed, which is main replay start sound. What else do we need when we start a game? Start the game, actually. Well, since this is a game about tiles, the tiles should appear here. Yeah, the tiles should appear in these slots. So they can appear just instantly in this place, or, which is better and more interesting, they can fall from above into these slots one by one, like this, fall one by one. So we can do that easily because, yeah, I have already created the scripts and now we just need to reference them. Let's create another sequence called create source tiles. Why create source tiles? Because this is the source and it will create its 6 tiles. So let's have a look at what source API provides. Let's see, it has source create tile call. So let's create tiles. Source create tile. Since we need 6 tiles, we do it 6 times. 6 times. Okay, 6 times. And once the sound has been started, we create source tiles. So the start sequence, once executed, it first does what? It first replays the start sound and then creates source tiles, which is another sequence, and create source tiles sequence does what? It calls source create tile 6 times. 1, 2, 3, 4, 5, 6. And that allows us to create 6 tiles. Let's reload. Let's move the camera a little bit far away and let's press space. Okay, we can't really see anything because we can see the node, but nodes are empty because I have not copied the tile model and the tile textures to the project, so let's do that. As you can see, there are errors when materials and the models are not found. As you can see, there is no model and there is no material. So yeah, let's copy those from rehearsal project. So first model, tile OSGT to models and pipeline textures. Tile to pipeline textures. As you can see, there are a lot of tile textures. Why there are so many textures? Well, because the Domino game contains 28 combinations, and each combination is represented by a separate texture. So we have 0, 0, 0, 1, 1 2, then 0 2, 1 2, 2 2, and so on up to 28 in sum. So I just copied 28. As you can see, 0 0, 0 1, 0 2, 0 3, 0 4, then 1 1, 1 2, 1 3. Basically each texture represents a combination. So we have copied the, as you can see, we have copied the textures for the tile and the tile model. Now let's define the tile material so that it can be referenced by the game. So tile, text, PNG, tile and PNG, and we need to do that for all combinations, as you can see here. So we will need everything. Well, that's not very hard, but let's do this. So as you can see, the tile, the normal map stays the same for all tiles, but the texture, the diffuse texture changes. So let's do this. Two, 3, 4, 5, 6. Okay, let's rename it. It's 02, then it's 03, then it's 04, then it's 05, then it's 06, 06, and 06. Let's see. 00, 01, 02, 03, 04, 05, 06. 00, 01, 02, 03, 04, 05, 06. Okay, now a few more tiles, textures, and materials. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. So 1 1, 2, 3, 4, 5, 6. Rename it. 1 1, 1 2. Okay, that will be easier to rename. Okay, 1 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Okay, now 2 2. Okay, now 2 2, 3 4 5 6. So 2 3, 2 4, 2 5, 2 5, and 2 6, 2 6. Yeah, right. Now let's 3 3. Let's do 3 3. 3 4 5 6. 3 4, 3 4, 3 5, 3 5, 3 6, 3 6. Now let's do 4 4, 4 4, 4 5 6. So 4 5, 4 5, 4 6, 4 6. Now let's do 5 5, 5 6. And finally 6 6. Yeah, that's correct. So let's recheck the materials. So 01, 00, 01, 02, 03, 04, 05, 06, 11, 12, 13, 14, 15, 16. Right. 2 2, 2 3, 2 4, 2 5, 2 6. 3 3, 3 4, 3 5, 3 6. 4 4 4 5 4 6 5 5 5 6 and 6 6, so 28 all in all should be. Let's reopen. Okay. Let's reload. Okay, tile texture is not present. Why isn't it not present? Because alright. So there's no tile, nothing. It all starts from the tile 0 0. Okay, let's reload. Reload? Yeah, fine. Now, I have just created 28 materials that reference 28 textures. And what I initially wanted to do is create 6 tiles. So I call source create tile 6 times when the game starts. Let's recheck it. Move the camera a little bit away and press space. Okay, as you can see, 6 tiles have been created. They have been created above the visible space. Let's see. Yeah, as you can see, they're above default camera view. This is done so that they can now fall down to each to its own slot. So let's do this. Let's see the source API, and it has drop source drop last created tile. So let's update the sequence. Source drop last created tile drop 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 drop. So we create tile and drop it, create tile and drop it, create and drop, and we do that 6 times. Let's reload and press space. Okay, that's okay. Not so simple because I have not copied the actions file. The actions file, because the actions are used to move the nodes. So let's copy the actions file from rehearsal project. So default actions, copy here. Let's have a look at it. What we need to look now, yeah, this action. It's a move action named lower tile in the group default. It says what? It says that it's not relative. It means that it is absolute. It moves from current position to the specified one, and it does so in 0.2 seconds, which is 200 milliseconds. So falling is basically changing the Z position to 0 in 200 milliseconds. That's what a fall is. So let's reopen. And press space. Okay, as you can see, all 6 tiles have been created and have fallen down, each into its own slot. Let's review it. So when we press space, the start sequence is activated. The start sequence does what? It replaces the start sound and then creates source tiles. And to create source tiles, the following sequence is executed, and it does what? It creates a tile, then drops it. It creates a tile, then drops it, and does it 6 times. So that's what we see here. When we press space, 6 tiles are created and dropped. The next step is to create the filter here at the center. Okay, we will do it after a small break. Let's have a 5-minute break and then continue with the filter. Okay, let us continue. So, just a reminder for everybody, this is a live session of Open Game Studio where I show how one can use OGS editor to create a simple game. And this live session we create the domino based game. So what is a domino, in case somebody doesn't know? In domino there are 28 tiles, starting with the 0-0 combination, then 0-1, 1-1, and so on up to 6-6. 28 tiles in sum overall. So this domino based game purpose is to move tiles from the source through the filter to destination. There is no yet filter and destination, only source so far. And as you can see, the tiles are colored. The white color means nothing, and the presence of any color means 1 digit. So basically what this tile means is 1-1, and this 2-1, and this one is 3-3, and this tile is 4-6. This one is 5-5. Okay. So now we need to create the filter, which will filter the source tiles that we select to decide if they can go to destination or fall down and are rejected. So let's copy the filter model and filter textures from the rehearsal project. Filter OSGT to models, and pipeline textures filter to pipeline textures. Let's create the filter material right away. So let's create it at the bottom. It doesn't really matter where, but let's do that here. So again, the filter material consists of one diffuse map named filter text and one normal map named filter N. So let's go back and let's add a new node. Let's call it filter and make it the child of base, and let's assign the model. Where is it? Filter. We need to, okay, now let's reload the project, and now let's add the model. For the node, make it child, and now select the filter model. Okay, let's move it up a little bit. As you can see, again, it's pretty ugly because no material is applied except for default one, and default one is pretty ugly. The lighting is wrong, so let's select the filter material I have just described, and now it looks a lot better. So let's move it a little bit down again. Okay, that looks like a good center. Okay, let's move it down. Okay, and that seems to be correct position. Let's create filter tiles. Let's copy the source leaf, paste it, make it child, and rename to filter leaf 0. So let's let's use orthographic projection for better fine-tuning. Let's move it a little bit down. Okay, that seems to be good. Now let's create the intermediary parent node. As I described, it's necessary for now, but will be unnecessary in future versions, because for now we cannot rotate one node around another one, so intermediary nodes are necessary for now, but only for now. So, and let's create another leaf, make a child and rotate it. Okay, let's look, let's reload. Okay, so this is our filter with 3 slots. Let's assign it the filter script. Okay, the filter script, let's copy it from Domino rehearsal project. Let's reload. Okay, filter is somehow not child of the base. Let's make it a child of the base. Yeah, right. That's correct. Assign filter the filter script so that we have the filter API. Reload. Okay, so what do we have now? Let's reiterate again. We have the following sequences file, and when we start the game, we do what? We replay the sound and then create source tiles. Create source tiles is another sequence, and it does what? It calls source create tile and then source drop last created tile, and then does that 6 times. It does it 6 times overall. So that gives us the following. Let's have a look at it again. I press space. As you saw, the 6 tiles fell down one by one. Now, since this is a filter, it also needs a tile on its own to filter tiles from the source, to check tiles from the source. So when we start the game, we should also create filter tile. Let's do this. First, let's have a look at filter API. Yep, here it is, filter create tile. That's the first call, and then we need to drop it. And then we call filter drop last created tile. Let's edit filter create tile and filter drop last created tile. Let's reload. Press space. As you saw, when I press space, the start sequence is executed and 6 tiles have been created for the source and 1 tile for the filter. So what now? Now we need to be able to select tiles. Now we need to be able to select tiles. And once we do select a tile, we should get something like this. The source should rotate so that it aligns with the filter, like that. So the source should, for example, we select this tile, and the source then rotates like that, and the filter then rotates like that, and then the tile goes from here to here. That's what should happen once we select a tile at the source. So when we select the tile, first thing we need to do to allow for that, for selection, is to allow tile selection. source allow tile selection. Let's have a look at the source API. Allow tile selection. Here it is. Source allow tile selection. This call at the end of the start sequence allows us to select for the source to listen to tile selections. To listen to tile selections, before that call happens, the source doesn't care what has been selected and where. Once this has been called, allow tile selection, the source listens to tile selection, and once tile is selected, it runs the following sequence: source tile selection. It runs source tile selection. So let's create it. Source tile selection sequence. So what should happen once we select a tile? Well, first thing we should do is disallow tile selection, because we don't want to mess things up. However, once the selection finished, we want to allow it again, so first we disallow, then allow. Now that alone does nothing but changes the availability of selection. So once tile has been selected, we do what? We disallow tile selection, and then we need to rotate the source to align with the filter. Let's have a look at the source API. Okay, we have that call. Source align select tile with filter. Source align selected tile with filter. Let's check it out. Reload, press space, and select the tile. And as you can see from above, that selected tile is now aligned with the filter. Now we need to align the filter to the source so that it can catch the tile. Filter. Okay, let's check what filter call we can use. Filter align filter align free slot with source. Filter align free slot with source. Let's call it align free slot with source. So it basically finds the free slot and aligns it with the source. Let's recheck it. Start the game, select the tile. So they are now aligned, as you can see. Now we need to assign that tile to the filter, and then that tile should fall into the slot. So who manages assignment? The assignment is managed by the main script. So it should have something like assign call. So it has it. Assign selected source tile to filter. Basically what it does is simply changes the parent from source to filter. Assign selected source tile to filter. Why the main? Why not filter? Why not source? Because both source and filter should not know about each other. Only the main should know and act as an intermediator, as a mediator, right? So we assign the tile from source to filter, and then we need to drop it. Let's see it. Filter drop last accepted tile. Let's use it. Filter drop last accepted tile. So now once the tile is selected, we do the following. First we disallow further tile selections, then we align the source with the filter, then we align filter with the source, then we change the parent of the tile from source to filter, then we drop the tile to the filter slot, and then we allow more tile selection in the source. Let's recheck, reload, start it, select tile, okay, select another one, okay, good. Now what we need is to perform algorithm which checks if two provided tiles match this one. The matching algorithm works as follows. It checks that this half of the filter tile and this half of the filter tile present in here and in here. So for example, as you can see, that filter tile digit here is 4. 1, 2, 3, 4. So either of the two nodes should have 4 on one of its halves, and it does. So here we do 1, 2, 3, 4. We have 4, so that node matches. Let's check another one. Another one should now have empty because the 4 has already been matched, and this does not have empty, so both tiles are unmatched, and the algorithm should return false, failure, and these two select tiles should fall down here, and that's the end of that turn. So before we drop them, no, not before we drop them, we need to perform once at each source tile selection. We need to perform the algorithm if both filter slots are filled. So let's check how filled. Yeah, filter has the following call: if no free slots, perform algorithm. So let's add it. Filter if no free slots, perform algorithm. So what it does upon each tile selection is that if filter is filled, it performs the algorithm. If it's not filled, it does nothing. So if no free slot, so what we do when we after we perform the algorithm, it returns either true or false. So when true happens, when success algorithm succeeds, we perform the success sequence, which is algorithm success, and when algorithm fails, returns false, we perform algorithm failure sequence. So let's add them. Algorithm failure, algorithm success, algorithm failure, and algorithm success. So what should we do on failure? Well, the first thing we should do is return the filter to its initial rotation. Let's find the call. Filter return to initial rotation, just so that it is visible. Why? Just so that all tiles are visible normally. So filter return to initial rotation, and in both cases, either upon failure or upon success, the tiles either fall upon failure or go to destination. In either case, the source is left without two tiles, so we need, in both cases, to create it. So let's do this. Source, create tile and drop it, and do it in both success and failure. Let's recheck what we have now. Start the game. Now let's select random tiles so that they do not match. As you can see, we return to initial position and new tiles came to source, although it's weird. Okay, I copied the wrong thing. I should create source tiles only. I don't need to touch filter. Let's recheck. So we start the game. The start sequence creates 6 tiles for the source and 1 tile for the filter. We select a tile. The selection sequence is performed and the tile goes here. I select another tile, and now, as you can see, the filter has been returned to initial rotation, and the source got 2 new tiles because these tiles either fall down or move to destination, which is not yet present. So let's first drop the tiles if they are unmatched. So how do we drop the tiles? Let's see. First we need to drop unmatched tile, and we need to do that twice. So for algorithm failure, once algorithm fails, returns false, we do filter return to initial rotation, then we do what? We drop unmatched tile, and we drop unmatched tile again because we dropped the first and the second unmatched tiles. Let's reopen, restart, select a tile, select another tile, and they should fall now. Yep, they fall down. The new tiles have been created. Okay, let's see the fallen ones. As you can see, they are still present. We don't need that because that area is outside the view of the player, so we just need to destroy them. How to destroy them? We have filter destroy unmatched tile call, so let's add that. After drop, destroy and destroy. So if algorithm fails, we do what? We return filter to initial position, then drop first unmatched tile and destroy it, then drop second unmatched tile and destroy it, then create source tile, drop it to the tile slot, then create source tile and drop it. Now let's recheck. Select another one, and they should fall now. And as you can see, they are destroyed and it contains nothing. So the drop tiles are destroyed. And as you can see, we can continue and now basically play indefinitely if we don't match the tiles. Now, that would be a pretty boring game if we only just select a tile, it fills the filter and drops down. That would be really boring. So now we need destination here that will accept tiles once the tiles from the source match the filter tile. Reload, and let's add another model and its material. Let's copy the destination model, then let's copy the its textures, let's define the destination material. Let's recheck. Okay, let's add the node. Call it destination. Assign it to base. Okay, and set its model to destination. Here it is. Let's move it up a little bit. Let's move it right a little bit. A little more. Okay, let's use orthographic projection. Okay, we need the center. Okay, that's not the center. Yeah, that looks like the center. Yeah. We need to move it a little bit up. Let's move it up. Let's see closer. Yep, here it is. Now let's change its material to destination material. Okay, let's reload. Okay, here's the destination. It also needs leaves, like both source and filters. So let's copy a leaf from here, paste it, and call it destination filter, destination leaf 0. Assign it here, and move it a little bit up. Use orthographic projection for fine tuning. Move it up a little bit. Okay, that looks fine. Let's compare it. Well, looks fine. Let's add another leaves around it. Okay, copy, paste. Now again we need the intermediary node, which allows to fine-tune the rotation around one node around another one. So now it's 36. Now add another leaf, make it a child, rotate it to 72. Okay, proceed with 108. Proceed with 142. Oh no. 144. Yeah, right, 144. So proceed with another leaf. That's 180. Now add another leaf. Okay, add another leaf. Add another leaf. Add another leaf. And add the last leaf. Okay, reload. Okay, the destination is almost complete. It only needs its script. Let's copy its script from the rehearsal project. Reload. Select destination and assign its script. Okay. Let's change the camera a little bit, camera view, okay, to see this scene better. Okay, that now looks okay, that looks good enough. Save the camera position and save the project and reload. Okay, now let's press space and start the game. Okay, now when we select tile and perform the algorithm, we need to finish the success sequence of the algorithm success. So what happens when both tiles match the filter tile? They go here. So how do they go? First we align the filter with destination, then destination with filter. Right, so how do we align filter with destination? Let's have a look. Filter align used slot with destination. Let's use it. Upon success we do what? Filter align used slot with destination. Then we align destination. Let's see what it has. Align free slot with filter. Destination align free slot with filter. So upon source sequence we do, upon success sequence we do what? We align filter with destination and we align destination with filter. Let's check it out that it works. Okay, so to match a filter tile we need what? We need 4 and 5. So let's see if we do have 4 and we need 5. So we don't have 5, so let's just drop 2 tiles that make no sense to us and wait for new ones. Okay, here's the 5 on here. This will match this side, and 4 here. It will match. So let's select 4 and let's select 5. And as you can see, they have been aligned. Now I need to move that tile to here, that tile to here, and that tile to, let's say, here. So how to move the tile? Well, first thing to do, so we did the first thing, we aligned both filter and destination. Now we need to assign filter tile to destination. Again, main comes to the help. Assign filter tile to destination. Main assign filter tile to destination. That only changes the parent of the tile. So then the destination should lift the tile. How can I do it? It has lift last accepted tile. So let's do this. Destination lift last accepted tile. And so one tile should be lifted. Let's recheck. We need 5. So do we have 5? Here is 5 and here is 5. Okay, let's select this one and select this one. As you can see, one tile has been lifted and we also need to lift another one. Let's add it. Now we need to repeat these 4 commands. We align the next slot, we align the destination with the free slot, we assign the tile, and we lift it. Let's reload, restart. Okay, 1 1. We have one here, and we don't have another one, so let's drop 2 tiles, which we don't need. Okay, let's reload the game. It will be faster. So we need 2 2. Okay, we have only 1 2. Okay, let's reload again. We need empty and 5. So do we have 5? No, we don't have 5, but we have empty. Let's restart. So we need 2 and 3. So here is 2, and again there is no 3. Okay, let's drop unnecessary tiles. Okay, finally, here is the 3. And here is the 2. Okay, where is it? Here it is. Okay, the first tile, and now the second tile. Great. Now, as you can see, we moved 2 tiles from the source through filter to the destination. We select tiles here, they are checked here. If they succeed in checking, they go here. If not, they fall here, down here. So, well, technically this is almost all the game, but it would be incomplete because we would need to match only this tile always, and this is pretty boring and pretty much impossible because one combination cannot cover all other combinations, so we need to allow for more things to do. We need to allow, right after the successful transition of the tiles from here, from source through filter to destination, we also need to allow to select a tile here at the destination and exchange it with the filter one, so that we can alter the algorithm to better to play a more interesting game, let's say that. So what do we need? Right after the success sequence finish, we need to do what? We need to be able to select destination tile. So we need to allow destination to listen to its tile selection. Let's see. It has destination, allow tile selection. So what we do is at the end of algorithm success sequence, we do what? We do destination, allow tile selection. So we allow to select tile only after successful pass transition of 2 tiles. And when the destination tile is selected, the destination tile selection sequence is called. Let's add it. Destination tile selection. So once destination tile has been selected, first thing we need to do is destination disallow tile selection. We don't want to mess things up, so we only allow tile selection for a brief time. Now also, when source tile is selected, we need to disallow tile selection for destination to not only source but disallow everywhere, because when things are moving in the scene, we don't want anyone selecting anything. Only when we have stopped everything, we want to be able, we want to allow the user to do something. So the first thing we do when the destination tile is selected, we disallow more selections. Now we need to move the filter tile. First we need to align filter with destination. and then destination with filter, so that the last tile that filter now has should go to destination, and then the selected destination tile will go back to filter. Alright, so in steps. First we align filter with destination, and we do this by this call. We'll filter align filter slot with destination. Filter align filter slot with destination. As you remember, with the tile selection, with the success sequence, and actually as you remember with all other sequences, filter has several align functions, like align used slot with destination, align free slot with source, and now it also needs align filter slot with destination. So we align filter, now we need to align destination. Let's check its API. Destination align free slot with filter. Destination align free slot with filter. Okay, where destination align free slot with filter. Let's check. Reload. Okay, 2, 4. So we need 2. Here is 2, and 4, 4, 4. Here is 4. Okay, that's good. So now we can either proceed here, or we can select a new tile. Let's do this. As you can see, we aligned filter and destination. Now this filter tile should go here. Then we rotate destination so that this selected tile is aligned to here, and then we move it down here. And filter has no filter tile. Okay, now assign. We do that with the help of main again. Assign filter tile to destination. Assign filter tile to destination. Main assign filter tile to destination. That changes the parent, and now we need to lift it again. The destination needs to lift last accepted tile, and we do that with that call, destination lift last accepted tile. Let's recheck it. Okay, we need 2, 0. We have no 0. Okay, let's reload. Okay, we have 3 and 6, so 3 here, and we don't have 6. Okay, reload again. 1 and 5. 1, 1, 1, 1. No, 1. There is 5, but there is 1. No, 1. Okay, 5 and 6. 6 and 5. Okay, that's good now. And here is 6. So the tile is moved to destination. Now we select destination tile. Filter tile goes here. Correct. And now that selected tile should go here in place of just moved filter tile. So we rotate. Now we need to rotate the destination. Align selected tile with filter. Destination align selected tile with the filter. Once we aligned it, we need to do what? We need to the tile from destination to filter. Assign selected destination tile to filter. Main assign selected destination tile to filter, and then drop it. Let's check how to drop it. Drop last accepted tile. Okay. So filter drop last accepted tile. And that's it. We can all, yeah, so upon destination tile selection we do what? We disallow further destination tile selections, we align filter with destination, we align destination with filter, then we assign tile from filter to destination, then we lift the tile, then we lift the tile, okay, looks like I missed a step. No. Then after lifting we align selected tile of destination with filter, then assign destination tile to filter, and then drop filter tile. Let's recheck it. So 3, 6. Here is 3 here and 6 here. Okay, good. Okay. Let's select another tile. Right and right. Okay, that's good. Now I think we should return to its initial position. Yeah, let's return it to its initial position. Actually, we can always return filter to its initial position just as many times as we need. That's a good thing because what? Because then the tiles are seen better. So once the destination tile has been accepted to filter, let's return filter to initial rotation, and upon failure, actually we did it. Upon success we also did it. Actually we can return filter to its initial rotation after success too. Okay, let's recheck it. Okay, so we need 5, 0. 0 we do. 5, yeah, we do have both. Let's do that. Okay. Now, so we don't have any empty here left, so maybe we need this. Here we have 5 and 6. So here we have 5 but no 6. Still we can change it. Okay, that's good. Now let's proceed. We need 5 and 6. We don't have 5. I mean, we don't have 6, but we do have some other things. Let's drop them. We still don't have 6, but we have things we can drop. Alright, so okay, let's drop these two. Okay, yeah. So currently we have what? We have the source that is filled at the start, and the filter which is filled with 1 slot, which has 1 slot filled at the start. Then we do what? We select 2 tiles here at the source, they go to the filter, and if they match the filter tile, they proceed to destination. If not, they drop here. If we want to change the filter tile, we can do that right after successful match, and right after two tiles move to destination, we select destination tile and it is exchanged with filter one. That's basically all the game. Yeah, that's actually all the game, but it misses a few things. First, there's no end, and the end happens when destination is filled. So when destination is has no free slots, the game should end. And once the game ends, we should calculate the score. And the score is calculated as follows. We take the sum of all the values of tiles the destination has and subtract the sum the source has, and displayed here. Here will be shortly LCD. Shortly, yeah. So let's add the LCD. Copy the LCD from rehearsal project. LCD model, LCD textures, and LCD script. Okay, let's do this. Copy the model first, LCD. There are two models actually. There is LCD base and there is LCD digit. Copy both two models. Also copy their textures. There are a few textures, basically one texture for each digit. 1, 2, 3, 4, 5, 6, 7, 8, 0. Copy that. And copy the script, the LCD script. Let's commit it. Almost there. Let's push it. Okay, I just pushed it. So that's almost complete game. Let's introduce LCD. Let's introduce LCD. Reload. Add a node. Call it LCD. Choose the model LCD base. Okay, make it child of here. Rotate it. No, move it up a little bit. Rotate it by, let's say, nope. Where is it? Okay. Yeah. Rotate it. Now add more nodes, like LCD digit 0. Make it a child of that. Assign model LCD digit. We need 4 digits, so position them correctly. Copy it and paste it. Copy it and paste it. Copy it and paste it. Okay. We have LCD with 4 digits. Now we need to assign their materials. Let's define them. Default compositor. So first thing, we need LCD material. LCD material consists of two textures. Let's recheck them. Right, LCD base and LCD, base normal and base diffuse. And also we need LCD digit material. Each material for each digit. One material for each digit. One, two, three, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all digits. Let's reload. Come closer. And assign correct materials. So LCD gets LCD base, gets LCD dark. Now digits get what? LCD, they get LCD digit material, every one of them, each one of them. It looks like an empty digit. Reload. As you can see, the LCD can display up to 4 values. However, we don't really need that many still. Let's move it into here somewhere. A little bit lower. Okay, that was correct. Save, reload. Okay, now we have the LCD. When the game starts, so what can we display in LCD? Well, the first thing we should probably display is number of source tile selections, so that it does not stay empty for the whole game. Let's do that. Wait, we forgot that LCD needs a script. Okay, reload, and now start. As you can see, we already provide the main provides 0 value. Now, upon each tile selection, we should increase its number. The main should have a call to do that. Yeah, increase selections number and display it. Let's edit upon each source tile selection. Main, increase selections number and display it. Increase selections number and display it. Okay. First selection, as you can see, the digit is the number the LCD displays is 1. Select another one, 2. So we use the LCD. Now we need to, the next step is to stop the game when destination is filled. So how do we stop the game? That's a good question. The destination should have something. Okay, maybe main has it. Oh, right. Finish the game if destination is full. Yeah, we need to call that at the end of each successful sequence. Of each success sequence finish. Probably. Finish the game if destination is full. Right. Or not actually at algorithm success, but just at the end of source tile selection. Yeah, because no, wait. After each successful match, right after everything has been rotated and moved, we should do that here. So we do main finish the game if destination is full. However, yeah, finish the game if destination is full. Finish, and it will lead to finish sequence. And in finish sequence, we would do what? We would certainly disallow tile selection for both source and destination, and we will also print we will also display results of the game with the LCD. So main display results. Yep. However, there is one problem, that the game will finish and will disallow everything, but the game finish will happen in the success sequence, and the source tile selection actually allows tile selection upon what? Upon end of the sequence. So source allow tile selection should be performed at the end of each algorithm, both failure and both success. Okay, now the game should actually be complete. Let's even reload the editor, open the project, start it. Okay, now we need 0, 5. We don't have 0, 5. We have 0, but no 5. Okay, let's reload. We need 1 and 5. So we have 5 and then we have 1. That's good. Oh. Okay, I actually broke the sequences because Because allow tile selection should actually happen when? It should happen... Okay, that's weird. If no free slots, perform algorithm and then... So when we perform the algorithm, we should disallow tile selection, right? Okay, disallow tile selection when we perform the algorithm, after we perform the algorithm. However, right before algorithm we should allow tile selection. Okay, reload. We need 3. Okay, do we have 3? No, we don't. Reload. We need 1, 3. Okay, reload again. We need 2 and 6. 6 and 2. We don't have 2, but we have 6. Okay. 1 and 2. 1 and 2. Did you have it? Now we can exchange 2 and 1. No, for now we don't. Okay, that seems to work just fine. Let's play it as a game, actually. So we need 1 and 4. 4. Here is 4 and 1. Here is 1. And here is 4. They move to here. So yeah, let's check that the game works fine. Now we need 1 and 4 again. So do we have 4? No, we don't. Okay, here we had 4 and 5. Okay, we don't have 4 at all. We have 1, but we don't have 4. Okay, without 4 it makes no sense. Let's drop this one, and let's drop this, no, not this one, but this one. Okay, we have 1, and we have we still don't have 4. Let's drop this one and let's drop this one. Finally we have 4, and finally we need to have 1 and 4. Yeah, that is better. So so we can exchange. We have 4 and we have 3. We can exchange with that one, or we have 4 and we have 5, and that's even better. So select this one as the filter tile. Okay, and now we can select 5 and 4. Okay, what else do we have? We need 4 and 5. So we have 5, but we don't have 4. However, we can. We don't have 4, right? We don't. So there is 2 5s, and we can take this and take this, and yeah, that's pretty fine. Replace the filter tile. And let's take this 5 and this 5. Okay, we need to fill 2 more tiles as destination. Now, as I said here, for now, it's the number of selections I did at the source tile, but when the destination is full, the game will end and the LCD will display the sum of this tiles minus the sum of this tiles. So the more here, the less here is better. And again, just a reminder, this is a domino based tile, so these are dominoes but represented as colored things. Now 5 5, we definitely don't have it, but we have 1 6 1 6. We don't really have 1 6, so it doesn't fit us. We have 1 5 5 5. We don't have 1 5, so 4. We don't have 4. We have 6. We don't need 4s. We have 5. Ah, we don't have 5. All right. 5 5 4 4 4 4 and 5. So we need either 5 or 4. We do have 3, although yeah, we have 2 6. Okay, let's take this one as a filter tile. We need 3 and we need 5. We have 3, but we don't have 5. Let's drop that one and drop that one. We have 4 and we have 2. 3 and 5. Okay, drop that one and drop that one. Okay, we have 5 and we have 3. Great. Now the game should finish. And it should display the result. Yep, 48. Nothing should be selectable now. Yep, the game has finished. So that's basically it. In just about even less than 3 hours, I recreated the domino-based game. Not from scratch, of course, but using the assets and scripts I created from scratch. And if you are interested in seeing how to do this from exactly zero, you can have a look at it at YouTube. The links will be published shortly. I already published it a little bit earlier, and we will publish it at our site. at opengamestudio.org. Here, once I finish the live session, I will post all the links and this video too on our site, so you can have a look how to create that game from scratch. Today I showed you how to recreate it using the ready assets, ready scripts, by reproducing the scene and reproducing the behavioral sequences. So that's basically it, but of course I can replay it now. Let's save it. The game is complete. Okay, I pushed it to here. So Domino live session at our GitHub repository now contains a complete game. Let's replay it again just to show what it can do. So open the created project and play it. So we need 1 and 2. So this 1 and this 2 will produce more score, bigger score, larger score. Okay, now we can either proceed with 1, 2, or before we clicked anything, we can exchange with this. We have 2 and we have 6. That's good. So we can provide 2, 2, 2, 2, 2, 2, 2, and 6. Now we need what? Either 2, 6 or something else. We don't have 6, but we have a lot of 5s. We have what? We have 5, but we don't have 1. So I'm not sure it will do. We would also get away with 6 and 4 and 2 and 1. Well, actually, there is a lot of 5s, but not 1. 6 and 2. Alright, let's replace it. Now let's drop one of the 5s. Or rather use that one, right. We need to drop that and that. So 1 is here and 5 is here. Okay, 5 and 1. So we have 4 and 5, and we do have 4 and 5. Let's replace it. So select the 4 and the 5. Mm-hmm. 6 and 2 might... No. 6 and... Oh, we have 4 and we have 6. So 6 and 4 will do fine. So 6 and 4. Here is the 6. And here is 4. Okay, end of the game. 35. Worse than I did before. So yeah, I'll just replay the game again. And just to recap again, in less than 3 hours, I recreated the domino based game. Its purpose is to move tiles from source through filter to destination. And the result at the end of the game, the game ends when the destination is full. The result is this sum of tiles minus this sum of tiles. As you can see, 35 is less than 48. I did score last time. So yeah, strategy is important in this game. So that's it for now. Thanks for watching. All material will be available shortly at opengamestudio.org. See ya.